So section P5 is on multiplying polynomials or maybe multiplying monomials to start. And multiplying is way less restrictive than adding or subtracting. When you had to add or subtract monomials or add or subtract to simplify polynomials, you needed to have like terms. Not an issue at all with polynomials. You can multiply any monomials slash polynomials. You don't have to have any worry about like terms. This section is ridiculously long. It has close to 140 problems. So we're going to, for homework, just do every other odd. I think it's going to be 1 through 137, every other odd. And I'll do the same in the video. I'm not going to do every even problem because there's just too many of them. And I think just doing half the problems is going to be enough. And by every other odd, I'd mean like 1, skip 3, do 5, skip 7, do 9, skip 11, do 13, skip. So it's going to be like 1, 5, 9, 13, 17, dot, dot, dot. So every fourth problem starting with 1. So the first 16 problems are just multiplying monomials, and that's super easy to do. To multiply monomials, which I have here in problem 2, 8 is a constant monomial. 4x cubed is a third degree monomial. To multiply monomials, you multiply the coefficients by the coefficients, you multiply the variables by the variables, and multiplying the variables is really adding the exponents. In problem 2, to do the multiplication, I'm just going to multiply the 8 by the coefficient 4, and I'm not going to do anything with the x. I'm just going to write this as 32x cubed. I shouldn't do 4, but I'm going to. Anytime we have a multiplication problem, if you don't like the order of the multiplication, you can switch the order. Multiplication is commutative. So if I was doing problem 4 and the order bugged me, I can flip-flop the order and make this negative 9 times 5y. And for me, that just feels better to have the constant term first and the term with the variable written second. And these two parentheses written next to each other without a sign, that implies multiplication. Now I'm just going to multiply the negative 9 by the coefficient of 5. I'm going to get a negative 45. And I'm going to leave the y. And that's all there is for that problem. These problems go really quickly at the beginning of this section. And then there's some kind of involved, tedious problems as we get deeper. So you can skip 3. I just wanted to point that out. In 6, I'm multiplying the monomial 12y cubed, coefficient 12, variable part y cubed, by the monomial 4y, coefficient 4, variable y. To do this multiplication, I'm going to multiply the coefficients of 12 and 4, and I'm going to multiply the variables of y cubed and y to the first power. That second y has an exponent of 1. The variable multiplication is adding exponents. The coefficient is just generic multiplication. So my answer for this, because 12 times 4 is 48, and when I add the exponents of 3 and 1 on the y, I get 4, is 48y to the fourth. There's going to be a handful of fraction problems in this section. Let me just do problem 7, not that it's a homework problem, just to show you we don't need to be afraid of fractions. To do problem 7, I need to multiply 2/3 times 6/5, and I need to multiply x squared times x. When we're multiplying fractions, you don't need common denominators. When I multiply fractions, I usually cross-cancel denominator to numerator before I multiply. And if I was doing number 7, because it's multiplying, I don't need common denominators, but because of it's fractions and multiplying, usually I cancel and then multiply. And the 3 and the 6 that I circled, I can cancel. I can go 3 divided by 3 is 1, 6 divided by 6 is 2. And now I'm going to multiply the 2's that are left in the numerator, the 1 and the 5 that's left in the denominator to get the fraction part of my answer. So the 6 and the 3, that started in the problem of change. Now in the numerator, I multiply 2 and 2 and get 4. In the denominator, I multiply 1 and 5 and get 5. And for the x's, I add the exponent of 2 and 1 and get 3. Not that it was a homework problem, but I want you to see, I don't want to avoid the fractions just because it kind of came up that way. If I was doing problem 10, I'm getting a glare here. I don't know if I can get rid of that glare. Maybe a little bit. At number 10, I'm really multiplying 1y cubed times negative 1y to the first power. The coefficient of the first monomial is 1. The coefficient of the second monomial is negative 1. So if I'm doing the multiplying, I'm multiplying 1 times negative 1, which is the coefficients. I'm multiplying y cubed and y to the first, which is the variable part. 1 times negative 1 is equal to negative 1, so the coefficient of my answer is going to be negative 1. And if I add the exponents on the y's, I get y to the fourth power. This is a completely acceptable answer. I kind of like this answer, but it would equally be okay to just write negative and then y to the fourth. If you have a negative sign preceding a variable without the 1's implied. So I'm going to jump down to skip 12 and do 14. For you, you should be doing on this page 13, 17, I don't know if you could see it yet, but 21. I skipped the fraction again. I'll be darned. I don't know how that worked out. Let me just do this fraction problem real quickly. I know it's probably taking too much time. But for 11, I should multiply 2/3 times 7/4. I should multiply the x in the left parentheses by the x in the right parentheses, the y squared in the left parentheses by the y in the right parentheses. I'm going to give each of the x's the implied exponent of 1, and the second y its implied exponent. To do the fraction multiplication, I'm going to cancel the 2 in the left numerator with the 4 in the right denominator. I'll go 2 divided by 2 is 1. 4 divided by 2 is 2. And now I'm going to multiply across. I'm going to go 1 times 7 is 7. I'm going to go 3 times 2 is 6. I'm going to add the exponents on the x's and get an x squared. I'm going to add the exponents on the y's and get a y cubed. That would be kind of a best answer for problem 11. For problem 14, this second monomial, or the second factor, has a coefficient of 1. So to do this multiplication of monomials, I'm going to multiply the 3 and the 1, the coefficients. I'm going to multiply the x and the x cubed by adding the exponents, and the t squared and the t to the fourth by adding exponents. 3 times 1 is 3. The first x that didn't have an exponent has an implied exponent of 1. So for my answer, I'm going to get an x to the fourth power and a t to the sixth power. Hopefully we wind up getting some fraction problems as we get deeper in this that we don't have to skip. 17 through 36 gets slightly more complicated. We're multiplying a monomial by a binomial for most of these problems. And it's not particularly hard. We just have to distribute the monomial through the binomial and do more than one multiplication. To do problem 18, the monomial 4y that's in front of the parentheses needs to be multiplied by the 2y cubed that's in the parentheses that it's left of, and by the negative 3 that's in the parentheses that it's next of. So I'm going to need to do 2 multiplications, and then after I do the multiplications, I need to put the proper sign between the results of the multiplications. It's either going to be a positive or a plus sign or a minus sign. First multiplication, I multiply 4 times 2 and get 8. I add the exponents on the y's and get y to the fourth. Second multiplication, I multiply 4 times negative 3 and get the sign that I need, negative, followed by the 12. And I just leave this y because there isn't another y to make it change. I can't go further. I can't subtract those because in order to add or subtract when you have a binomial, you have to have like terms, and like terms not only need the same variable, but they need the same exponent. For 22, I don't like the way it's written, and anytime I have a multiplication problem, if I don't like the way that multiplication problem is written, I can flip the order because multiplication is commutative. And if I was doing problem 22, for me, I would probably take the time to rewrite it, and now I'm going to do the multiplication that's needed. I'm going to take the 2y that I have in front of the parentheses, multiply it by the 3y to the fourth. I can show that multiplication with a time sign or with a parentheses, it doesn't matter. And I need to multiply the 2y that's in front of the parentheses by the 5 that's inside the parentheses. So now I'm going to go 2 times 3 and get 6, y to the first times y to the fourth, add the exponents of 1 and 4 and get 5. And then for this next multiplication, I'm just multiplying the 2 and 5 and getting 10. I'm going to leave the y. I have to have a sign between the terms, and because this is positive, I'm going to put a plus sign between the terms. Again, I can't go further. I can't add these and get a 16 y to some power, because once you're in the adding and subtracting, simplifying part of working with multiplication, you have to have like terms, and like terms have the same exponents on the letters. So on this page, you should be doing 25, there's a fraction, 29, and 33. I'm going to start with 26. For 26, I'm going to multiply negative 3 times 4x and negative 3 times negative 9. The first multiplication, I just multiply the negative 3 and 4 and get negative 12. Should probably be writing equal signs, but I'm not so great about that. Second multiplication, negative 3 times negative 9 is positive 27. Two negatives multiply to be a positive. I need signs between the terms. I forgot the x for the first term, and it should be a plus. I don't know how readable that is. So my answer should be negative 12x plus 27. This is written in a nice order because the leading term or the term with the highest exponent is first. Ugh, now we get nastiness. If I was doing 27, I'd multiply negative 2x times 5x squared. I'd multiply negative 2x times 3x. I'd multiply negative 2x times negative 1. If I do every odd problem, it's going to be like a 2-hour video, and I don't want that to happen. So I'm going to jump down to 30. And for 30, I have to do 4/5 times negative 3x. And I have to do 4/5 times 15. For the first multiplication, I'm going to take this negative 3x and write it as negative 3x over 1. And I look to see if I can cancel. I look at the 5 in my left denominator and the negative 3 in my right numerator. If those were cancelable, I would reduce. Similarly, I look at the 4 in the left numerator and the 1 in the right denominator, and those aren't cancelable. So what I'm going to do now is multiply the 4 and the minus 3 and get minus 12. I'm going to multiply the 5 and the 1 and get 5. And I'm going to leave the x. I can either write the x in the numerator, or I can write the x off to the right of the fraction. If a numerator of a fraction only has multiplication, and it has a variable in the numerator, that variable can be left in the numerator or can be drug off to the right edge of the fraction. Next multiplication that I need to worry about, 4/5 times 15. I'm going to write the 15 as a fraction by putting it over 1. And then I'm going to cross cancel the 5 and the 15. I'm going to go 5 divided by 5 is 1. 15 divided by 5 is 3. I'm going to multiply 4 times 3 and get 12. And I'm going to multiply 1 times 1 and get 1. So that second multiplication is going to be 12 over 1. And 12 over 1 is just equal to 12. it's positive, so when I put it in my answer, I'm going to put a plus 12. I can't go further. After I do the multiplication, I'm in the adding and subtracting portion of simplifying, and there aren't any like terms here, so I can't go further. Cool. So 33 is our next problem, or your next problem. Mine's 34. In order to do 34, I need to take the 2x that's in front of the parentheses. I need to multiply 2x times 5x cubed. I need to multiply 2x times negative 6x squared. I need to multiply 2x times negative 7x. And I need to multiply 2x times 1. I usually wouldn't show this line, I would just do it in my head, but I want to emphasize what I'm doing just in case this is new for you. First multiplication, I multiply the 2 and 5 and get 10. I add the exponent that's implied of 1 with the exponent of 3, and I get a 10x to the fourth. Next multiplication, 2 times negative 6 is negative 12. I add the exponent implied of 1 with the exponent of 2 and get x cubed. Third multiplication, 2 times negative 7 is negative 14. Each of the x's has an exponent of 1, so when I add the exponents, I get an x squared. Last multiplication, I'm just multiplying the 2 and the 1 and getting 2. I'm leaving the x. Since it's not negative and I need a sign between, I'll put an addition sign. So we should do 33. If you want, take a stab at 35. I just don't want this video to be monstrously long, so I'll skip the fraction explanation, but we'll get more fractions as we get through the section. When we get to the second page, we're multiplying two binomials, and you're going to do 37 and 41. And when you're multiplying two binomials, you need to multiply each term in the left parentheses separately by each term in the right parentheses. So the 5x in the left parentheses, I need to multiply it by the 6x and the 4 in the right parentheses. Let me start by doing that. So first I'm going to multiply the 5x in the left parentheses times the 6x in the left parentheses. Sometimes we call this multiplying the first entries in each parentheses. And this style of multiplication, when you're multiplying one binomial times another, is often referred to as FOIL, and I'll talk about that in a second. But my first multiplication, I start with the 5x in the left parentheses, multiply it by the 6x, and then I multiply it by the 4 in the right parentheses. This second multiplication, 5x is furthest outside or furthest left in its parentheses, 4 is furthest right in its parentheses. In this multiplication, we generally call these the outers. From the FOIL acronym, F means first, O means outers. It seems like overkill to have a word for what we're doing, but there is one. I'm done with the 5x. I've multiplied it by both terms in the right parentheses. Now I'm going to move on to the negative 2. I'm going to multiply the negative 2 in the left parentheses by both the 6x in the right parentheses and the 4 in the right parentheses. When I do the multiplication of the negative 2 and the 6x, this is the I part of FOIL. These are considered inside. So the 5x and the 4 are outside, the negative 2 and 6 are the inside of the parentheses. So we would call this inners. And when I do the multiplication of negative 2 times 4, negative 2 is the last thing in its parentheses, 4 is the last thing in its last term in its parentheses. We call that lasts. So the acronym of FOIL comes from the first letters, first, O for outers, I for inners, L for lasts. That's technically what most instructors will teach when you're multiplying two binomials to do FOIL. Let me do the multiplications and then I'll see if I can combine like terms and write my answer in a nice order. So first multiplication, I multiply the 5 and 6 and get 30. I add the exponents on the x's and get x squared. Second multiplication, I just multiply the 4 and 5 and get 20. I leave the x. I always need signs, either addition or subtraction, between the terms. Since this is positive, I'll put a plus sign. Next multiplication, I multiply the negative 2 and 6 and get negative 12, and I'll keep the x. Last multiplication, negative 2 times 4 is negative 8. Generally, when you do foiling, or when you multiply two binomials, we say that the middle terms can be combined. The 20x minus 12x, those are like terms. Like terms have the same variables with the same exponents. Those can be combined by taking 20 and subtracting 12. I should probably write equals, because this equals to the original problem. For an answer, the 30x squared and the minus 8, they don't have anything to combine with. They're not like any of the other terms. But the 20x minus 12x, I'll go 20 minus 12 and get positive 8 and leave my x. My answer to 38 should be that. When I do foiling, I want to write my answer in a good order, and that's highest exponent, middle exponent, and constant. I'm going to do 42 now. I'm going to start off with the 5 in the left parentheses and do the firsts. Multiply the 5 in the left parentheses by the 4y in the right parentheses. Then I'll take the 5 in the left parentheses, multiply it by the negative 1 in the right parentheses. We call that outers. Rather than writing the whole word, I'm doing symbols. Then I'll done with the 5 because I've multiplied it by both terms in the right parentheses. I'll start with the negative 3 in the left parentheses. I'll do the negative 3y in the left parentheses, multiply it by the 4y. We call that inners. And then the negative 3y in the left parentheses times the negative 1 in the right parentheses, and we call that lasts. I don't think the acronym is that necessary. You're just taking each term in the left parentheses, multiplying it by each term in the right parentheses. First multiplication, I multiply the 5 and 4 and get 20. I leave the y. Second multiplication, 5 times negative 1 is negative 5. I just write negative 5. That's going to wind up being last in my answer. Third multiplication, I multiply negative 3 and positive 4 and get negative 12. I add the exponents of 1 and 1 on the y and get a y squared. And then last, negative 3 times negative 1 is positive 3, and I leave the y. To simplify this, I need not only to combine like terms, but I need to write it in a nice order. So one of the parts of my answers is going to come from combining 20y plus 3y. That's going to be 23y. Again, I should be writing equal signs because what I'm writing is equal to the original problem. So part of my answer is 23y. The other parts of my answer are the negative 5 and negative 12y squared. Negative 12y squared has the highest exponent. It should be written first in my answer. Minus 5 is a constant. It should be written last in my answer. I need signs between each of the terms, and because 23y is positive, I'll sneak a plus sign between. And that'll be an answer for 42. So hopefully you can push through and get done with 43. So we should be jumping up to 46 next. So on this sheet, we're going to do, here's some fractions. We're going to do 46 and 50. Well, you're going to do 45 and 49. Am I right? Yeah, I think I'm right there. So ugly, ugly, ugly. Maybe I'll walk through 45 with you. Maybe pause the video, try to do 45, and if you can't, I'll do it. You can watch me do it. So I'm going to start off taking the 1/2 x in the left parentheses. I'm going to multiply it by both terms in the right parentheses. So I'm going to do 1/2 x times 3/2 x. That's called firsts. Then I'm going to do 1/2 x times minus 5. That's called outers. Then I'll start with the 6 in the left parentheses, multiply it by both terms in the right parentheses. I'm going to multiply 6 times 3/2 x, and I'm going to multiply 6 times minus 5. I got some ugliness to deal with here. In the multiplication for the firsts, the hard part is multiplying the 1/2 by the 3/2, but it's not particularly hard. The 2's in the denominator don't cancel with the 1 nor the 3 in the numerator. So to do that multiplication for the first, the coefficient part, I'm going to go 1 times 3 is 3. I'm going to do 2 times 2 is 4. So the fraction part of the multiplication for the first is going to be 3/4. The exponents x and x, I'm going to combine and add and get x squared. The next multiplication of the numbers I need to worry about is going to be 1/2 times -5. And when I multiply the 1/2 coefficient times that constant -5, I'm going to write the -5 as a fraction. I'm going to write it over 1. And then I'm going to multiply 1 times -5 and get -5. I'm going to multiply 2 times 1 and get 2. So that's the coefficient of the outers, or the second multiplication. It's going to be -5/2. And I'm going to leave the x. When I get into the world of the inners, this is the inner part, and this is the last part. For the inners, the coefficients are 6, and I need to multiply 6 times 3/2. I'm going to write this as 6 over 1 times 3 over 2. And I notice I can cross cancel the 6 in the left numerator by the 2 in the right denominator. I'm going to go 6 divided by 2 is 3. 2 divided by 2 is 1. And then I'm going to multiply. I'm going to multiply 3 times 3 in the numerator, 1 times 1 in the denominator. I'm going to get 9 over 1, which is equal to 9. So when I go to do the inner part of this, the coefficient's going to be +9, so I put a plus sign, and the variable part's just x. For the last, 6 times -5 is -30. I'm almost ready to write an answer. The x squared term, 3/4 x squared, is going to be part of my answer. The -30 is going to be part of my answer. I need to do better and combine the inners and outers. And in order to do that, I need to take the coefficient of -5/2 and add it with the coefficient of 9. And in order to do that, that coefficient of 9, I'm going to make a fraction by writing it over 1. And then I'm going to get a common denominator by multiplying that fraction 9 over 1 by 2 over 2. This is going to make this -5 over 2 plus 18 over 2. Once we get the same denominators, I can make the two fractions added by putting the numerators next to each other. And then in the numerator, the -5 and the 18 have opposite signs. So when I add those, it's really subtracting. If they have the same signs when you're adding, you're really adding. They have opposite signs when you're adding, you're really subtracting. So the numerator is going to be -13. The denominator is going to be 2. My middle term is going to be -13 over 2. And the variable is going to be x. For the first term in my answer and the middle term in my answer, those x's can be brought into the numerator. It would be completely fine if I wrote an answer of 3x squared over 4 minus 13x over 2 minus 30. That would be equally good. That was disgusting. If you want to, try 47 if you want to do a fraction by yourself. If not, well, I don't think I put fractions on the test. I just want to expose you to some fractions. So I'm going to move on to 50 and do the 4 multiplications. If you notice problem 50, the parentheses are identical. Each has a 4x and a 5, except one has a plus and the other has a negative. When this happens, when you're multiplying binomials that are essentially identical, except one parentheses has a plus sign, the other has a minus sign, we call those conjugate pairs. And there's a quick way to multiply conjugate pairs that we'll get to that you might know already. But there's an efficient way to get the answer. But to start off, I'll pretend I don't know anything about multiplying conjugate pairs. I'll take the 4x in the left parentheses. I'll multiply it by the 4x in the right parentheses. We usually call that firsts. I'll multiply the 4x in the left parentheses by the negative 5 in the right parentheses. We usually call that outers. Then I'll take the 5 in the left parentheses and multiply it by the 4x in the right parentheses. We usually call that inners. And then the 5 in the left parentheses times the negative 5 in the right parentheses, we usually call that lasts. First multiplication of the first, I multiply 4 times 4 and get 16. I add the exponents on the x's and get x squared. Second multiplication, 4 times negative 5 is negative 20. I leave the x. Third multiplication, 5 times 4 is positive 20. I leave the x. Last multiplication, 5 times minus 5 is minus 25. And when you're multiplying conjugate pairs, the outers and inners, or the middle terms, always cancel because they're going to be opposites. And when you add opposites, they cancel. My answer to problem 15 is just going to have the firsts of 16x squared and the lasts of minus 25. And your answer for 49 should be similar. And we're going to maybe pause the video because I'm at 31 minutes. You could do 49. You don't really need to do 51 right now. I'm going to pause the video and we'll start a part 2. There's probably going to be a part 3 to this section.